So question 2 over here then says, given the geometric sequence, geometric important, -1/4, b, -1, 2.1, calculate the possible values of b, show your working, for 3 marks. So geometric sequence, here's our geometric sequence, here's our geometric series that does end, and here's our infinite series over here. Our infinite series over here when our ratio is between -1 and 1, which means what we're dealing with over here based on our original sequence is actually an exponential graph. But for this limitation, when we reach infinity, it means we're approaching 0. And that's because we have a ratio that brings us down to 0, just like our exponential graph would, or up to 0, just like our exponential graph would. It gets closer and closer and closer until it almost touches 0, but that is why we can ultimately add them all up from here to here with this equation and then get a round value, compared to this one over here where we have an exponential, but it starts curving away, which means it just keeps going and going, and same thing over here, which means we cannot add up all the numbers for them, and that's why we just look at a certain range over here at a starting point and an end point, so we can just add up all the numbers over there. Okay, but with that, we are given the geometric sequence, so we know we're working with these guys over here. So we have -1/4, b, and then -1, and ... Okay, so they want all the values of b, show your working. So this is unknown, and the best way to solve this, because we don't have enough information to plug it into a formula, because we can't yet get a and r, because this is unknown, which means geometric sequences have ratios. Arithmetic sequences have differences, as we saw previously, but these guys have ratios, and the way that we get a ratio, how much we multiply this term by to get the next term, is by going t3 over t2, make that equal t2 over t1, because we will have a constant ratio from here to here and then from here to here again. But we just divide them backwards, because ultimately what we're doing is we're multiplying this first term by something to get this next term, which means we can then go ahead, we see that this is t1, this is t2, this is t3, and then we can just plug them in accordingly, so we can then solve for our b algebraically. So t3 is -1, t2 over here is b, and that equals t2 over here, which is b, over t1, which is -1/4. Okay, at this stage we're going to cross multiply, so b times b is b squared, -1 times -1/4 is 1/4. Right, now back to the question. They said the possible values of b, which means we will have more than 1, because if we square root this over here, we will square root this side, and this is the same as dots, when we have b squared -1/4, and that equals 0, because then we would just go ahead and open up our brackets like this, and that equals 0 like dots. So this is just another way of doing dots, which means if we take the square root of 1/4, we will have plus or minus. So plus or minus, square root of 1 is 1, square root of 4 is 2, so we have plus or minus a half over here. And that is our answer for b, all the possible values of b, showing all our working, earning us 3 marks over there. From there, we're on 2.2, where they gave us the answer to work with. So if we couldn't get the answer in 2.1, they're telling us work with this answer over here. But this is also a nice way to see that, okay, we have an answer that they've given us. Let's see if I can try and get that answer over here in the previous question, if we were struggling or not sure of the direction to go in. But they're saying if b equals a half, calculate the 19th term of the sequence, because now we know we have -1/4 there, we have b as a half over here, and then we have -1 over there, which means we can go ahead and get our ratio by putting t3 over t2 or t2 over t1. We just made them equal each other to solve for something that was unknown. But if we do t3 over t2 or t2 over t1, we will have the same ratio on both sides, because what we're trying to do is plug it in this formula over here, because we want the 19th term of the sequence. They didn't mention series, they didn't mention adding all of these up, which means we have to work in this formula, getting our a, our r, and then our n, which they have told us being 19. So we have tn equals a multiplied by r to the power of n minus 1. So if we work with this side for our ratio, we have -1 is our t3 over a half over there. Okay, and this equals -2. So -2 is our ratio, because that is how much we multiply this term by to get to the next term, and this term by to get to the next term. And then our a in this formula is the first term in the sequence, which is -1/4, which means tn equals -1/4. That's our a multiplied by r, which is -2 to the power of n, which is 19, considering they told us over here, minus 1, because that is just a part of our formula. So then at this stage, they're just numbers over here, so we can plug it in our calculator and get our answer. And our final answer is minus 65536. And just remember, when you substitute values in here, always put brackets around them in case our negative doesn't get the right exponent. Exponents on a negative that has brackets versus a negative that do not have brackets can give us a different answer. So always just plug in with brackets. Cool. And that is our final answer over there, earning us 3 marks.